Hello, I am going to explain motion of a particle under time-dependent force F. This force is not ordinary, it is time-dependent, and it is not constant, it is varying. Therefore, and motion of particle means I want to find the displacement of particle at any time t. And we start with the second law of motion, which states that the force is directly proportional to rate of change of momentum, and we can write F force equal to rate of change of momentum with respect to time, which means momentum change can be written as F time dt. Here momentum is where momentum is equal to m into v. Therefore, d momentum in terms of mass into velocity is equal to F dt. Since mass is constant, therefore we can write mass d times v is equal to force times change in time. Now we will integrate this equation number 1 with initial conditions that when t is equal to t0, v is equal to v naught, and at t is equal to t, later on anytime t, v will be equal to v. On integration, equation number 1, we can write m integration of dv from v naught to v naught to v equal to integration of this, that goes from t naught to t f dt. Now mind this, that force cannot be written outside the integration because it is time dependent. On solving integration, left hand side gives me m into v minus v naught, means upper limit minus lower limit is equal to same t naught to t f dot dt. Now we cannot integrate because I do not know what is the nature of this force, so I will keep this equation as it is, which gives me, I take this mass to right hand side, we get v minus v naught is equal to 1 over m, same integration t naught to t f dot dt. And taking this v naught to right hand side, we can write v is equal to v naught plus 1 over m 0 to t f dot dt. Since v can be written as v, we can write as dr by dt, and here r is displacement, and when t0 in starting, r displacement was r naught, let us say, and at t is equal to t, r will be equal to r vector. Therefore, we write this equation in terms of r. We write this v as dr by dt, this left hand side, and right hand side as it is v naught plus 1 over m integration again from t0 to t, here also we have t0, then f dot dt, and it gives me taking this dt to right hand side, we get dr is equal to v naught times dt. I multiply this dt to first term, that is v naught, I get this, plus 1 over m, because mass is constant I can take it out, so I multiply 1 over m here, then I have to multiply dt to this term, so I write this term in bracket from t naught to t f times dt into, again we have to write dt. Okay, now let us integrate both sides again with these conditions which are written here. So I will use these conditions to integrate this part. So I will write dt dr, integration of dr from r naught to r, which I have written here, equal to v naught dt, its integration from t naught to t, plus this term, integration of this term, I will write 1 over m is constant, no need to integrate it, so integration from t naught to t, inside this bracket will remain as it is, f dot dt into dt, that integration of this part. Now solving for integration, this dr becomes r, and put the limits, we get here r minus r naught is equal to, we put this dt, integration of dt, that is t, putting the limits, we get v naught as it is into t minus t naught, because lower limit is t naught, upper limit is t, plus 1 over m, and remaining portion remain as it is, t naught to t, I have to integrate whole term f dot dt, and again dt here. Fine, we have two integrations, sorry, one integration we have lost here, that I have to write this integration here also from t naught to t, and that integration comes here also, t naught to t. So we have got two integrations, one outside and one inside the bracket, and taking this r naught to left hand side, right hand side, we get r is equal to r naught plus this v naught term, v naught into t minus t naught, plus 1 over m, first integration from t naught to t, then bracket, and inside also you have to make integration t naught to t of time dependent force dt, bracket close, then integrand of this, that is dt here. So this is ultimately the displacement of particle at any time t, under time dependent force. What would you write? You would write, this is the displacement of the particle at time t moving under time varying force F. So that's all to study the motion of a particle under time dependent force.